Welcome to The Explainer. Looking around today, it really feels like artificial intelligence just popped out of nowhere, right? We turn on our screens and suddenly AI is just everywhere. But here's the absolutely fascinating truth. Today's modern AI boom, it's actually the culmination of a century-old ambition. We're talking about a story filled with incredible visionaries, massive, devastating failures, and this relentless relay race of ideas spanning generations. So today, we're going to trace the exact lineage of the technology that is literally changing our world right now. Okay, let's dive into this. When was artificial intelligence actually born? I mean, if you had to guess, you'd probably point to sometime in the 1950s or maybe the dawn of the internet. But actually, scratch that. The blueprints for modern AI were sketched out way back in the 19th century. That is a full 100 years before the first electronic digital computer was even built. So to really understand where we are today, we've got to rewind all the way back to 1843. To wrap our heads around the massive paradigm shift that had to happen for computing to even exist in the first place, we have to look at two brilliantly contrasting minds. First, you have Charles Babbage, brilliant guy, inventor of the difference engine and the analytical engine. But Babbage's mind was completely bound by numbers. He essentially saw his incredible invention as just a magnificent mechanical number cruncher. But then, enter Ada Lovelace. She looked at Babbage's machine and saw something entirely different. She had this light bulb moment where she realized, hey, if a machine can manipulate numbers, and those numbers can represent other things, like letters or even musical notes, then the machine could manipulate symbols according to rules. It was a total game changer. She crossed the intellectual threshold from mere calculation straight into true computation. Lovelace's vision was so far ahead of its time, it's honestly almost staggering. Back in 1843, she was putting in grueling 18-hour days to write up a collection of notes describing Babbage's analytical engine. But here's the wild part. The machine she was writing programs for didn't physically exist. It was constantly changing in Babbage's own head. As historians point out, she was essentially writing code for a virtual machine. She completely understood that this device wouldn't just do math. Theoretically, it could create art, compose elaborate music, and act as a true general-purpose engine. And, the working relationship between Lovelace and Babbage was incredibly intense. If you actually go back and read their letters in the archives, they're hilarious. They read exactly like modern emails. They're abrupt, dashed off, full of quick questions and uncorrected typos. At one point, they actually had a massive falling out. Why? Because Babbage wanted to hijack her scientific notes to publish this angry political diatribe against the government. Lovelace absolutely refused. She had strict moral standards and wouldn't let the science get overshadowed by his rant. Realizing just how absolutely brilliant she was, Babbage eventually backed down, sending her a reconciliation letter that he literally signed, "Ever my fair interpretress, your faithful slave C. Babbage." So Lovelace basically proved that computation was possible, but it would take over 100 years for the hardware to finally catch up. Think of this 100-year gap like a giant relay race of ideas. The baton gets passed from Lovelace's theoretical 1843 notes, which just sat dormant until the mid-20th century, straight into the hands of Alan Turing in 1948 and 1950, and then finally to the Dartmouth Workshop in 1956. This is the century-long relay race that quite literally built our modern world. Alan Turing essentially picked up exactly where Lovelace left off. In his famous 1950 paper, Computing Machinery and Intelligence, Turing asked a very direct, provocative question. Can machines think? And this is where he introduced the imitation game, what we all know today as the Turing test, where a machine is deemed intelligent if a human interrogator just can't tell it apart from a real person. But Turing went even further than that. He actually anticipated the concepts of machine learning and connectionism. That's the idea that networks of simple artificial neurons could mimic the human brain. He suggested that instead of hard-coding a machine with rigid rules, maybe we should teach it the way we'd educate a child, letting it learn, adapt, and grow over time. So by the mid-50s, these ideas are just floating in the air, right? Turing is talking about thinking machines, other folks are debating neural networks and cybernetics, but the whole field didn't actually have a unified name. Enter John McCarthy. In 1955, McCarthy is writing a grant proposal to the Rockefeller Foundation, asking for about $13,500 to fund a summer workshop. And he specifically coins the term artificial intelligence. Why that term? Well, he deliberately wanted to dodge the heavily charged baggage of the word cybernetics, which had gotten all tangled up in rigid control theories and dystopian sci-fi tropes. He based this new name on a really bold conjecture that absolutely every single aspect of learning or intelligence could, in principle, be described so precisely that we could just build a machine to simulate it. Now, what's really interesting about this is the sheer vertiginous ambition of these four pioneers. You've got John McCarthy, Marvin Minsky, Nathaniel Rochester, and Claude Shannon. They organized the Dartmouth Summer Research Project for the summer of 1956. And their goal? To gather a small group of scientists for just 2 months and make significant headway on simulating human intelligence. Think about that for a second. They genuinely believed that a 2-month summer camp could solve, or at the very least crack open, the deepest mysteries of the human mind. But, well, here's the surprising reality of that legendary 1956 Dartmouth workshop. It was actually a technical half-failure, or as they called it, a demi-échec. The researchers didn't even work together the whole time. People were just coming and going at their own pace. They didn't produce a massive technical breakthrough, and there wasn't even a unified research paper published at the end of it. Honestly, if you just looked at the raw technical output of those 2 months, you would probably wonder why it's even in the history books at all. But the true impact of Dartmouth wasn't some specific piece of code. It was the birth of a collective identity. For the very first time, these incredibly smart, scattered researchers looked around and recognized, hey, we're all working on the exact same goal, under one shared name. This workshop essentially became the founding myth of the entire field. And over the next 2 decades, that shared identity unlocked billions, with a B of dollars, in public funding, especially from DARPA. It launched a 70-year trajectory that gave us early systems like the ELIZA chatbot and the Shaky robot. Now, as you can imagine, with all that DARPA money flowing in, those early pioneers became wildly, dangerously over-optimistic. Listen to this quote from Herbert Simon in 1965. He said, "In 20 years, machines will do any work a man can do." I mean, they were literally promising the moon. They assumed that just because they had solved basic logical proofs and simple little games, general human intelligence was just right around the corner. But, spoiler alert, this immense over-optimism ultimately set the entire field up for a massive, devastating crash. This hubris triggered an absolute disaster for the industry in the 1970s. We're talking about a devastating chain reaction. By 1966, the ALPAC report comes out and reveals that machine translation was a total failure. I mean, translating Russian to English was just spitting out absolute nonsense. And boom, $20 million in funding gone. Then, in 1969, Marvin Minsky's book Perceptrons highlights the severe limits of early neural networks, which effectively put that research on ice. By 1973, you have the Lighthill Report, which led to the complete dismantling of AI research in the UK. They pointed out the combinatorial explosion, which basically means algorithms that worked fine on simple toy problems just completely ground to a halt out in the messy real world. And the final nail on the coffin? In 1974, DARPA slashed academic funding after a massive speech recognition project failed to deliver a system that could actually understand a pilot's voice commands. So this chain reaction led straight into what we now call the AI winter. Basically, a deep freeze in funding and interest. The crucial thing to take away here is why it happened. It wasn't just about technical limitations, it was the hubris. AI researcher Hans Moravec later admitted that he and his colleagues got caught up in this web of increasing exaggeration. They kept overpromising just to secure those big grants, and when they couldn't deliver, the government entirely lost patience. Moravec noted that DARPA explicitly slashed those multi-million-dollar contracts to almost nothing, specifically to teach them a lesson. But the research did survive the winters. The theoretical foundations laid by Lovelace, Turing, and the Dartmouth crew, they were fundamentally sound. They just desperately needed more data and way more computing power. Fast forward to today, every single large language model you interact with, whether it's Claude Opus, GPT, you name it, is the direct descendant of those early Dartmouth projects. These AI systems that can write code, analyze complex images, and compose music, they are the great-grandchildren of the ELIZA chatbot and the distant cousins of the Shaky robot. They are simulating intelligence today with a precision that would have absolutely stupefied John McCarthy back in 1956. So, what does this all mean for us? Why does this historical journey actually matter today? Because it's absolutely crucial to realize that the tech industry isn't just reinventing the wheel right now. What we are experiencing today is the execution of the exact vision those 8 men had at a summer camp 70 years ago, which itself was based on a brilliant idea a visionary woman had over a century before that. We are simply taking a 70-year-old ambition and finally putting it into production. Which leaves us with a truly fascinating question to ponder as we wrap up this explainer. The Dartmouth pioneers boldly conjectured that every aspect of intelligence could be simulated. It took us 70 decades of massive boons, freezing winters, and just relentless research to get to the incredibly fluent conversational AI we have right now.
If it took 70 years to get here, what on earth is artificial intelligence going to look like 70 years from today? Thank you so much for joining me for this explainer, and as always, keep learning.